Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, girls. How are you? Hope you're doing good and fine. Welcome to our lesson part 3, electricity. We learned that electricity starts from atoms, and we learned that atoms are the building blocks of all matter. Also, they are very tiny and small that we cannot see with our own eye. We need a special microscope just to take a look at them. Alright, before I start my new lesson, I would like to revise the most important information for today. Okay? First, we know that they are all charged up. And by that I mean atoms sometimes gain or lose electrons, okay? Gaining or losing electrons will change the positive or negative charge of the atom, definitely. So if it's neutral atom and it gained electrons, it will have a negative charge. But what if it loses an electron? It will have a positive charge, just like the red one. Yes, definitely. So we know that atoms gain and lose electrons. Excellent. Also, we know that opposites attract. And how is that? Particle with the same charge repel or push away from one another. Definitely. Also, the opposite charges attract one another or pull together. So whenever two atoms have the same charge, they repel. And if they don't have the same charge, they have different charges, they definitely will pull together. Excellent. Okay. A static electricity. What is a static electricity? We said a static electricity is the build-up of electric charges on an object. So static means not moving. Alright, what do I mean by the building up? Just like the example of the comb yesterday, when you brush your hair, all the negative or all the electrons move from your hair to the brush, and all the positive charges are lifted up on your hair, so they are building up on your hair until they stood up. So this building up, we call it a static electricity. Yes. All right. Today I'm going to teach you about lightning. Lightning and thunderstorm. Thunderstorm can really be scary, but lightning can be really dangerous. Do you know that? Today we are going to know how lightning can happen. Alright? Now, before we know that, let me tell you that static electricity is a build-up of charge on an object, and we know about it. We said that a comb, you remember the example about the comb and the hair. Okay, charge stays where on an object until it comes close to an object that has a different charge. So your hair will definitely will be up until some different charge comes and change the way, right? As you walk across a carpet, this is another example. As you walk across the carpet, electrons move from the carpet to you, all right? Because electrons repel each other, they spread out all over your body, all right? When you touch something, the electrons jump from your finger to the object, okay? This jumping is called electrostatic discharge. Please remember this word, electrostatic discharge. You feel it as a tiny shock. Look at this picture. I'm pretty sure that you have been in this before. When you touch someone, you feel a little bit shocked and say, oh, what is that? Electricity? Definitely it's electrons. Electrons are moving all over and all the way. So when they jump, electrons, when they jump from a person with a negative charge, you feel a zap. Yes, that's it. So the explanation of it, we call it jumping. Jumping, electrostatic discharge. So the explanation, just like what we read over here, that electrons repel each other, so they spread out all over your body, so they need to be touched with some opposite charge so they can jump up. When they jump up, they what do? They make a shock, all right? And this shock, we call it electrostatic discharge, all right? Now, first, let's do this exercise, page 488. An object with a negative charge, this is the cause, I'm telling you the cause. I want you to tell me the effect. When an object with a negative charge is placed near an object with a positive charge, it will affect what? It causes what? It will what give you? Yes, definitely. Electrons jumps from the negatively charged object to the positively charged object. Excellent. And what do I call this jumping up? We said electrostatic discharge. Excellent. Now let's learn about lightning and how lightning is happening. Now, you must know that not all electrostatic discharges cause small shocks, just like the one with your finger. No. Some of them result in huge shocks, just like what? The lightning. Yes. Now I will teach you step by step what is happening during a thunderstorm. During a thunderstorm, raindrops and ice particles bump into each other, causing what? An electric charge to build in the clouds. So, where does the positive charge will go and where does the negative charge will go? That's what I'm going to teach you now. Positive charges form at the top of the cloud. Look at the picture. At the top of the cloud, there are positive charges. Also down on the ground. Okay? On top of the cloud, it has a positive charge. Also, on the ground, it have a positive charge. Negative charges form near the bottom of the cloud. Can you see the bottom of the cloud? It has a negative charge. Now, imagine what could happen. When the difference in charge between a cloud and the ground is great enough, lightning occurs, definitely, because we know that opposite charges attract each other and they cause a lightning, all right? And a lightning is a huge electrostatic discharge. What did I told you about electrostatic discharge? It must touches something that is opposite of charge. That's why it jumped up. Yes, it jumped up. Now, I want to tell you a small information about lightning. Lightning can be really hot. Do you know that the temperature inside a lightning bolt can reach 27,760 Celsius, which is hotter than the surface of the sun? This is really hot. And lightning can strike, okay, And when it strike, it catch object on fire. Yes, it can put an object on fire. And also, a tree struck by lightning may split, just like the picture on the left side. Can you see it? The lightning just split the tree into two halves. This is too dangerous for us. Now I want you to stay safe from lightning. So let's learn about how to stay safe from lightning. You have to stay inside during thunderstorm, then turn off electrical appliances and stay away from window. If you can't get inside a safe structure, wait in a car with a metal top for the storm to pass, alright? Know the weather forecast if you will be outside. Have a plan in case a thunderstorm develops, alright? These are the steps how you can stay safe from a lightning. Now, after you know all of these things about lightning, do you think you can do the drawing about the cloud and the ground? Where are the charges gonna be? Where are the positive charges and the negative charges going to be? Okay, without going back to the picture, try to draw it on your own. Then you can go back to the picture and see if you did it or not. And if you got it, please put a big check and a big star for yourself from me. Thank you, my girls, for listening to me. That's it for today. See you tomorrow in a new lesson.